Hello and welcome back to Steam It with Steve. Today we're going to have a look at how to handle errors within our code. Now this is one of the most important parts of a good computer scientist, is to be able to recognize the difference between a syntax error, a semantic error, a runtime error, and then also a logic error. So let's jump in and sort of unpackage what that might look like. I've got a bit of a joke there. Sorry, you can see it. And that's what it feels like to be a really good computer scientist. So if you make progress, if you get rid of a bug and then the error message is different, that's actually a really good thing. So let's go through the things that we're going to cover today. So where did a bug in the system first come from? How to check for errors, the three different aspects of a language, which is the syntax, the semantics, and then the pragmatics. And then the four main types of errors that are available that we'll face. So syntactical errors, semantic errors, logical errors, and then also runtime errors. So we're going to have a real deep look at all these aspects so that you understand what each of them mean and how that sort of impacts the code that you do. By understanding the different errors that you face, you'll start seeing patterns, and then you'll be able to fix the errors a lot quicker as well. So the first bug in the system, believe it or not, it was actually a bug in the system. So computers used to be really, really big, like taking up sort of warehouse sort of space. And what it was actually a bug that was trapped inside of the system, which is there. So this is actually the very first bug in a system, believe it or not, which happened in relay number 70, it looks like, in panel F. So it was actually a moth that fried, and then it blew up the whole computer that stopped the programming. So this is the first actual case of a bug being found, which is kind of cool. So yeah, that was something a bit of interest. So the most useful line for testing errors in Python, from my personal experience, is using the printx statement. This is so handy when you're trying to work out what went wrong. So by typing printx, you can just type it in the variable that you're interested in, and then output it into the console and understand what went wrong. So if we looked at this two train tracks together, what is it? And have a bit of a pause and think about it. So does it work? Would it work? What needs to change to it to make it work? These are the sort of things you need to think about. Awesome. So hopefully you had a bit of a think. So the things that you need to think about, is it a failure? So is it totally broken and it's wrong? You need to just wipe it away and say, nah, can't do it. Is it an error? Is it a fault? Or does it need to be specify what the desired behavior that you're trying to get it to do first? Is that what has to happen? So it is an error in this erroneous state. So if you just had the train going across as fast as you can, it's probably not going to work out in its favor. So it could also be algorithmic fault. So the two tracks have been trying to put together, and then there's no train actually been live running through it. And then you still have the opportunity to try and fix it because it's still the fault has been found, and then you can play around with it. It could be a mechanical fault. So the ground's just all of a sudden fallen out of it underground, and then now it's not going to connect. So it could be a mechanical fault with the operating system behind the scenes. So then how do we deal with this type of fault? Well, there's a couple of different ways. The first one is with verification. So that's where we wrap our compiler through it and see if the syntax is working. So every time you press the play button inside of PyCharm, you should have seen that it runs if all the syntax or the structure of the code works. So verification, if we had a train track that looks like this with a loop-to-loop, it would actually verify because the compiler would say, yep, everything's all good. The train could potentially go through. You can then do modular redundancy. So that's where you put another layer of code over the top of it, such as that. And that's possible, but then the problem is the code gets a little bit big and expansive. You can then declare the bug as a feature. So putting a tightrope thing on it and try and balance and get across, which is possible. Probably not the best thing using features, but it does happen from time to time. And then you can also do patching, which is what most people sort of do. So patching, you recognize that there is a fault, and then you connect in and try and sort of make it work the best that you can. So it's not going to be ideal. You probably don't want the train going 100 miles per hour, but it's still better than nothing. The other thing that we do usually when we have something like this is we try and test it. So testing, instead of running the huge train down and going as hard as we can, we might do a little bit of code just to see what happens and run it on a smaller system and try and identify what's going on, and might be able to go back and forward over a certain area to try and work out what happens. So who tests the software? Well, there's two different types. You have a developer, and then you have an independent tester, which we call a pressman. Now, both are valid and both have the advantages and their disadvantages. So a developer understands the system, but then they will gently test the system because they're driven by the delivery. They don't want their code to break, otherwise they don't get paid, and then they also get fired, right? So they won't try and break the system, and they won't go as hard as possible, but they understand the system better, so they can give a lot more feedback. Whereas an independent tester or a pressman, they want to break it. They will try and see everything that's wrong with it and try and work out ways to break it when you don't even think that it is possible to break. So they're driven by the quality of the product. But the problem is they must learn about the system that's been built. So there is advantages and disadvantages in both. When you test, you might actually probably want to get both to try and test the system, and then you get different insights into what's gone wrong, and then you can also try and fix them, which is kind of cool. So terminology that we need to unpackage is reliability. So that measures the success of an observed behavior of a system compared to what was specified. The failure, which is any deviation of the observed behavior from the specified behavior. An error, which is the system in the state such as further processing by the system that will lead to failure. And then a fault, which is a bug, which is a mechanical algorithmic cause of the error. So these are all different things that we need to consider inside the terminology that you've covered. There are many different types of errors, and there's a whole heap of different ways that you can handle them. By understanding this terminology, though, it sort of gives you at least insight into the world, and then it makes it a little bit easier. So how do we deal with errors? Well, sometimes we just give up. What I usually try and do if I'm in sort of a rut with the same error happening over and over, I actually try and walk away for a second, go grab a drink, and then I come back with a fresh vision of what's happening. So some of the easier ways to do it is with verification. So your compiler or PyCharm is your best friend. Down the bottom, it tells you all the errors. And as you're typing in the top right hand corner, it actually tells you any warnings or fault total huge errors as you're going. So then you can know what's happening. So it assumes hypothetically the environment does not match the real environment when you're building it. The proof that happens with verification might be buggy. So like you saw with the loop-to-loop, the code might be compiled well, so the syntax or the structure that you've made is correct, but the actual logic is all over the show and doesn't make sense. So that might be wrong. If you do modular redundancy, that's okay, but it's expensive. So you got to use more memory, more processing time, and it's not as ideal. You can then declare the bug a feature, which is bad practice. Please don't do that. And then you have patching, which slows down the performance, which isn't so ideal. And then lastly, we have testing, which is never good enough, but it is the best practice. So dealing with errors, testing is what we try and do. And we always want to try and find as many of the issues that are happening inside of our code and resolve them from the very beginning. So as soon as you see errors as you're typing it, it's very good practice to try and resolve it before you go too far. My little thing is I like trying to build a little bit, test it, then move on and integrate it. I don't like running all my code and then pressing run and going, oh, why didn't that work? It's a normal thing. So there's two states of every programmer. One where you feel that you're a god and you can control the world, and then the other side where you have no idea what's going on and you're freaking out. They're totally valid. And the more you practice this, the more this actually happens. So errors are common. Don't get too flustered by them, but try and sort of work through them. That's the really important bit. So dealing with errors during a project lifecycle, we try and do error prevention. So before the system is released, we use good programming methodology to reduce the complexity, use version control to prevent inconsistent systems, we apply verification to prevent algorithmic bugs, and then we use error detection. So while the system is running, we do tests galore. So we try and create failures in a planned way, and that's might be the data that we try and enter into the system to try and find the faults that come together. We then also want to do debugging. So start with unplanned failures. So as you're working through the application, something comes up, You list and very clearly specify what went wrong and then how to replicate that issue again so that someone else can look into it. You then want to monitor, so deliver information about the stats that are happening, and then you might want to start finding some performance bugs. So the computer program might be running fine, but it might be using a lot more memory than is what was expected. So you might be able to find a performance bug that might improve how the program goes, sorry. Then you have error recovery. This is where you recover from failure once the system is released from the issue that's come in. There are three aspects of every single programming language. There's syntax, which is the form. So this requires the grammar, punctuation of the language. So if there's missing a semicolon, the indentation's not working, that is a syntactical issue. EBNF diagrams can help showcase that to get your head around it. I'd highly recommend having a look at those. And then you get compile time errors like syntax errors. So anytime you run the compiler, it generally gives you a little feedback once you press that play button. You then have semantics, which is the actual content. So what are you trying to talk about? And this is all about the meaning of the program. So what are you trying to do? Are you trying to count up to 6? Why are you trying to count up to 6? So what the statement do, what is the program does, and then also logic errors are sort of semantical errors. So semantic and logic sort of have this little gray overlap in the community, but it's really important to understand and differentiate between them. So semantical errors is just the meaning, whereas logic errors is where you might have been checking to see that X was less than 4, but actually meant greater than 4. And the last one that we need to know is for pragmatics, which is the use. So pragmatics are what are good and bad features of the language. So for example, you wouldn't try to build Fortnite with Python, and similarly, you might not want to do machine learning with something like C++. So my old professor loved Java, for example. So traffic lights, we've got syntax. So we've got green down the bottom, yellow, and then red. So that gives you the syntax or the structure. We then have semantics. So green means go, yellow go if it's safe, and then red to stop. And then lastly, we've got pragmatics. So if red and no traffic, then allowed to go. So another English example, if we do the syntax, what time is it? So that's the start. The semantics, question about the current time. So there's a bit more of the meaning, why we're doing this. And then the pragmatics, an answer to the question is obligatory, even if the time is unknown. So that gives a bit more of the context of why we're doing it. There's a good video there. I'll put the link in down below that shows the difference between syntax and semantics. The importance of syntax, correct syntax is obviously important. If you don't get it right, your program just won't run. So there's a little meme on the side there. No matter how many times you press the play button, if it's not working the first time, it's probably just not going to work. So this is usually a spelling or grammatical error. So you've missed a semicolon or you forgot to add in another parameter. It does happen. It happens still to me to this day. So in a sense, syntax is trivial. You'll learn it, you fix it, and until it's right, the compiler will run, end of story. So you keep trying to go over and over until you get it working. The syntax of a language is greatly affected, and this is how easy it is to write the program. Also how easy it is to read and understand the program, and how easy it is to make hard to see syntax errors. So there's a little bit of a joke for you. So if I had 12 tomatoes and take away 2, what is the difference? And then the boy yells out, exactly, I don't like tomatoes either. So then it goes to principal. What are you in for this time? Semantics. So semantics, hopefully you picked up, is the meaning that's happening behind here. So semantics, if we think about it, we break down sentences and work out the structure of what's happening. So this sentence, Lansky left Australia to study the piano at the Royal College of Music. So there's an institution, so we've bound that together, the Royal College of Music. The subject was the piano, the education was the study, and then the study links the student, the subject, and the institution together. Then if we go back up to the top, we've got departing, which we talk about who's departing, which is Lansky. They're departing Australia, and then they've got a clear purpose of why they're doing that. So that sentence, while it's simple, has a lot of meaning that's happening underneath it, which is what a good computer scientist tries to look for. So semantics has to do with the meaning of the constructs in the language and the meaning of programs written in that language. So semantics is fundamental to everything you do in a language. Syntax is just the code that you use to describe the semantics, which is really, really important. So there's a little fry meme. So not sure if semantics or just syntax. That's a common thing that we will face as a computer scientist, trying to work out what it is. So a language cannot have semantics without syntax to support those semantics. So syntax is like the foundation, and then semantics allows us to build some stuff above that. The last one is pragmatics. So there's a bit of a meme for you. Pragmatism, no matter how trustworthy he may appear, do not give a monkey your pistol, because it's not pragmatic. So pragmatics has to do with how well the language connects into the real world. So semantics supports pragmatics. Some kind of language are better for different kinds of problems. So for example, if we're doing machine learning, Python's really good for that. Also any data analysis, if we want to quickly pop it in the data and see what's happening, any patterns, it's really, really good for that. Whereas if we want to build a game, probably not so good. So the choice of language depends on the pragmatic conditions that you want to evaluate before you get into it. Cool, so now we have the 4 different types of errors that you'll face. So first of all, we have syntax errors. So when a syntax error occurs, that's when the language has not been respected. So you put the wrong colons in, commas, all the different things are all over the show. The indentation's not right. You're not respecting the syntax. Semantics errors are a little bit different. This is improper use of the program statements. So syntactically, the structure is fine and it will compile, but you haven't really thought about the semantical meaning of what you're trying to do. Logic error is a little bit different. This is not respecting the specifications of the program. So not respecting what people are asking you to do and the logic behind the scenes. And the last one is runtime errors. And this is what can't be detected by the compiler at all. And this happens in the runtime. And we'll unpackage a couple of them at the end. So for example, if you divide by 0, if 0 is an option to input, that can't happen until the user inputs in 0 to break the system. So there's a little bit of a meme for you. So the compiler will look around, they'll see a logic, a runtime, and a semantic error, but will always pick on the syntax error. That's just sort of how they sort of function. So a syntax error occurs due to the wrong use of variables. So syntax of a programming language would be correct, but the problem may cause the use of the wrong variables, wrong operations, or in the wrong order. Sorry, there's a spelling error saying semantic error. So the compiler will generally catch these errors. That's the really cool thing about a compiler. So can you see the syntax error in the code down below? Just pause the video and see if you can get it. Cool, so what you should have picked up is input, should be input, and then print, I don't know, how do you even say that? So those are the 2 syntax errors, which is just simply being a typo. Now, if you run a good IDE like PyCharm, and I keep plugging it, but it's awesome, that it will underline those code snippets and say this isn't going to work before you even press the play button. So that's a really handy thing to sort of get your head around as well. So then if we fix that, we've now got the input right, we've got the ticket cost, and then that works. So a semantic error is a little bit different. Semantic errors occur due to the wrong use of variables. So the syntax of a programming language would be correct, but the problem may be caused by the wrong variables, the wrong operations, or in the wrong order. And then the compiler may not necessarily catch this, probably won't. So if we had something like this, order is equal to square brackets, complete equals yes, num equals 10, while complete equals no, so straight away there's something wrong with that. So the while loop won't run. Print, menu, sandwich, pizza, salad, the item equals input, what would you like? Order dot append the item that you've put in, and then num now equals num plus num. It's a bit weird, isn't it? So 10 is equal to 10 plus 10, and then that's just going to keep repeating if that loop even got started, which it isn't. And then complete equals input, are you finished? And then print out, you order menu items, and then print out the order. So first of all, what's menu? It's not even there. Print out order. It's just all over the show. So you should be able to see 4 separate things. So straight away, the yes is a problem. The number probably would want to start at 1 because you're going to go from the beginning. and then num that needs to be +1, and then the menu as well. That could be a bit of a problem to output it there. So if we wanted to fix that, you could go through and change it. So we're going to set complete to no, num is equal to 0, and then num is equal to num +1, and then we're going to print out you ordered num items. So that is the syntactic error. You then have a logic error. So this is where your code compiles and your program runs as planned, but the output is incorrect. So it's a little bit different from a semantical error. So semantical, like you saw, was just the wrong pieces in the wrong puzzle as they were going. A logic error occurs though due to a poor understanding of the problem. So you're not quite understanding how to solve the problem itself. So for existence, you want to find the module of a certain number. So the number divided by mod 4. Instead, you wrote the program for division. So you did divide by 4. That would be a logical error. Some may argue that it's a semantical error as well, but I like saying it's a logic because it's a bit more focused. These type of errors are considered to be logical. So semantic and logical errors, like I said, have this sort of gray area overlap. It's kind of up to you to work out what you feel works the best for you. It doesn't really matter. So in this one here, we've got product is equal to 0 for I in range 10. Product is times equals by I. Sum of the squares is equal to 0 for I in range 10. I square is equal to I star 2. Sum squares plus equal to I square. Nums is equal to 0 for num in range 10. Num is now plus equal to num. So num's going to add on to itself. So this will always result in 0, the first one. So if you look at that really carefully, product is equal to 0. For I in range 10, 0 times equal to I, you're always just going to have 0 times 0. So you might as well not even have those two lines of code. So we need to make product equal to 1. The next one, sum squares is not indented properly. So it's not going to work properly when we try and add on the I square because it's not inside the for loop. So that's a logical error. And then num plus equal to nums, that should be +1 probably. But again, it's up to whatever the code's trying to do. So an error that occurs while the program is running is a runtime error. Generally happens due to user input, and there's a whole heap of different ones that occur. They're usually time dependent, so usually after a certain amount of time something's occurred, and these are commonly known as bugs that can be solved during that debugging phase. Really popular inside of games, so gaming engines are notoriously buggy depending on what you're sort of playing with, and trying to work through those bugs and identify them is super important. So in this case here, there's a little example. So num1 is equal to the input of a number, same with num2, enter what operation you'd like to perform using add, subtract, multiply, divide. Now, if they divide, there's a big error here because potentially you could put the second number as a 0 and then break the code. So if the user puts a 0 in for num2 and then selects divide, the whole program is going to crash. So we need to make sure that has happened. So errors happen in galore. Stack Overflow is your friend with this. Make sure you try and use it. Don't listen to the people that roast you. They are Muppets. So some conclusion questions. How can your understanding of different types of errors improve your programming skills? In what way can error handling be applied to real-world computing situations? And discuss how the concepts of syntax, semantics, and pragmatics are interconnected inside of programming. There's a little Kahoot online. Hopefully that would help you understand and get a little bit deeper into this. The more you practice, that's my biggest advice, the better you'll get at this, and you'll be exposed to similar problems. So you'll start seeing patterns and then understanding, oh no, that's that same pattern that I've seen before. Then work out, how do I solve this? And then you follow that pattern again. So that's pretty much it from me. Hopefully you've enjoyed that. I've tried to make this pretty as easy as possible to understand the difference between syntax, semantics, runtime, and logical errors. So those are the 4 main ones, and pretty much every error can fall down into those 4 different categories. The more you practice, the easier it is, and you'll still start identifying these. So if you enjoyed this video, please give us a like and subscribe down below, as it does help with the YouTube algorithm. We're trying to promote Python and making sure that it's accessible to everyone, and making sure that everyone sees the beauty and how easy it is to sort of pick up this. And yeah, hope you've enjoyed. Got any questions, please put them down in the comments below. So that's it for me. See you next time on Steam with Steve. Adios.